Enoscope Instrument is actually having how to calculate the time in speed and out. So these three values are very important for us. Hi friends, in this video we are going to talk about different traffic studies, particularly related to studies of flow and speed. On the screen I have listed different types of traffic studies. Simply you can go through it. Traffic volume study, in the last video we have seen peak hour factor. There I told you we will be doing counting on the roadside, right? Whenever vehicles are coming, we are going to count it. Nothing related to this traffic volume study. Okay. Now the speed studies. There are different types of speeds which we have to calculate on the road. Generally we may be saying speed means we know that speed, na? Simply distance divided by time. But simply if you are doing distance divided by time, you are only getting the average speed of a vehicle. We need to calculate some other types of speed which is very important for various purposes. That all things we will see under speed studies. Okay, what are the instruments we are using and all. Then origin destination study is also there. Origin destination study, as the name indicates, we want to know from where all the vehicles are coming and to where these vehicles are going. Why we want to know that data actually? We actually want to know each road will be used by how many number of vehicles, which means it's somewhat related to this traffic volume study only, but it's a separate type of study. That's why we are keeping it as separate type of study. Just to understand which road is more important, whether road A is more important or road B is not more important. To check that, what we can do, we can just see the origin and destination of each vehicles coming at a particular session and see and understand the routes, in which route they are traveling. So based on that we can understand, okay, how many vehicles are using which particular routes and all. Okay. Then we can discuss each one in detail in the coming videos. I'm just giving an overview. Okay. Then traffic capacity study. As the name indicates, what do you mean by capacity? How many vehicle, what can be the maximum number of vehicle a particular road stretch can accommodate is known as capacity. We are having different formula for calculating the capacity of a road. We'll study in detail in that particular video. Okay. Then parking study. Parking study indicates how much width of road we require. Road in the sense roadside, okay, or parking lot we require. What are the different types of parking studies? What is the requirement of parking studies? Those things we have to study. Then comes to accident study. Accident study means in case some accident is happening, definitely we have to make a report on that particular accident. Okay, how the accident has happened, whether any whether it is a fatal accident or not, or if it is a minor accident or not, if anything happened for any human beings, or if it is just colliding between objectives only. Those things we have to report. Based on that we may be putting some control measures. So, sometimes we can put the signals, sometimes we can put some speed breakers, some speed limit signboards. So these things we are deciding based on this accident study. Okay. So recently updated GATE syllabus has removed this origin destination study has been removed. Origin destination study has been removed. Then parking study. These two topics has been removed from the recently updated GATE syllabus of 2021. But in other exams like SSC exams, various state government exams, they will be asking you questions related to origin destination study and all. Parking study, it is not that much important. It will be generally used to ask only in college exams, in university exams, for because it's a theory type of questions. And in IES also some type of questions has already came related to parking studies. We will see these things separately in different videos. In this video we are going to see the first two, traffic volume study and speed studies. Traffic volume study is not that much important. that we are going to use in all other different studies also, or everywhere traffic volume is required. Na? Without traffic volume, how we will analyze a road, correct? So it's a basic thing, it's a basic input data for all other types of studies. Okay, some data or some information we have already seen in the last class, how we are going to count the number of vehicles and how we are going to decide the peak hour on a particular day and all, right? So if we are counting the number of vehicles, either we can count it manually or we can count using some automatic counting devices. Obviously, which may be better, whether manual counting will be better or automatic devices will be better. You may be thinking it is automatic devices, right? But no, manual counting is always better because we can classify the vehicles also. In the sense, if we are keeping some automatic devices, maybe a bus is coming, then a car is coming, then a bike is coming. So automatic devices will count simply, okay, 3 vehicles, that's it. But if it is a manual counting, what we can do, we can separately classify that, like 1 bus, 1 bike, like that. Okay, vehicle classification is also possible in case of manual counting. Okay, that is an advantage of manual counting. Based on that, we can properly design the intersections and roads and all. Definitely, if 10 bikes are coming, 10 buses are coming, 10 trucks are coming, obviously the situation is totally different, right? So properly we can design based on the type of vehicles coming on that particular road. That's an advantage of manual counting. Okay. Now, if we are counting so many number of vehicles, just some theory point I am telling related to something related to traffic volume study, may be asked in state government exams and all. Suppose I am counting the number of vehicles for 1 week period. Let it be 1 week period I am counting. So suppose I got maximum, see, on one day I got 1000, on the next day I got 1200, on the next day I got some example I am telling, some 1500. Then finally I want to know, then what is the average vehicles in one day? Then what I have to do? We just have to add all those values divided with how many number of days we have counted, correct? So simply if I am taking that numerator, what I will get? Total number of vehicles counted right. So total number of vehicles counted in the counting period, whatever is the number of days, it can be 1 week, it can be 2 weeks, it can be 1 month, anything. What is the total number of vehicles you counted divided by the duration of that counting period in days? If it is 1 week, means we are going to divide with 7. Okay, if it is 1 month, if it is 30 or 31, whatever, we are going to put it in the denominator. Then what we will be getting? The total number divided by number of days. Obviously, we are going to get average value, right? So we call that average as average daily traffic, correct? In one day, how much it is average? Average daily traffic. There is a standard short form for this, nothing but ADT. Okay, average daily traffic. Okay, very simple. Everyone knows that. But there is another term which we call it as annual average daily traffic. That can be asked for some exams, maybe average annual daily traffic, or at least you should know what is the difference between this average daily traffic and annual average daily traffic. Simply what we have written here in the counting period, right? So what is this counting period? I told you it can be any duration, 1 week, 1 month, or some 10 days or 3 months, anything. If that counting period is 1 year, means completely in 2020, completely we are counting the number of vehicles and we are taking that very big value. If that value you are dividing with the number of days, then what is going to be the number of days? 365 number of days in that particular year. Okay. So what I can write the definition? Total number of vehicles in a year. Total number of vehicles in a year divided by number of days in that particular year. Okay, 365. Okay, so what short form I can put? AADT. Okay, these two are the most important definitions. If we are counting for one particular week, then we can call it as weekly average daily traffic, or if it is month in one particular month, then monthly average daily traffic. Like that we can make different definitions. Okay, so AADT is somewhat very important, which we are using to analyze the trend or traffic trend and all. If particularly in 2018, suppose if you are getting some 1000 vehicles per day as the average, in 2019 you calculated some other value, 2020 you got another value. So you will understand how the trend of traffic, how is the trend of traffic. We mainly use this trend value or growth rate in traffic payment designs and all. We need to know what may be the future traffic. Whenever we are designing a road, we are designing it for some 30 years and all, right? So after 30 years, how much may be the traffic, future traffic? To know that, we should know what is the trend of the traffic. So this growth rate and all, we used to analyze based on this AADT. So just remember the definition, can be asked for some state government's exams and all. Not very important concept, and concept is important, but it's not a complicated thing. Okay. So that's it about the traffic volume study. Very simple only. Meanwhile, in between other topics also you will be hearing this word traffic volume, traffic counting and all. Now we will move on to speed studies. Okay. There are two different types of speed studies actually. If we are simply classifying, the first type of speed study is sport speed study. The second one is speed and delay study. Speed and delay study. So what is the main difference between this first type of study and second type of study? In the second one, we are considering the delay of vehicles also. In the sense, suppose if you are traveling from one location to another location, in between you might be stopped your vehicle for some time. It can be because of the signals, or it can be because of some accidents, or it can be because of some particular control measures. So those things also we are going to check in some studies where we are considering the delay of the vehicles. We generally denoted it as speed and delay study. Sometimes you might have studied in your college moving observer method or floating car method and all, different names are there. That is somewhat related to the speed and the delay study. Okay, we will see everything in detail. So first of all, before directly going into sports speed study and speed and delay study, I am just going into the particular word speed. Okay, so we know what you mean by speed, nothing but we all know distance divided by time. Okay, so if you are taking distance divided by time, what actually you are going to get? You will be getting the average speed of that particular vehicle. Okay, and even this average speed we can split into two. If I am telling from one location A to B, suppose this is somewhat 60 kilometers apart. A vehicle is started from A and it has taken suppose 2 hours to reach B. Then what speed I will be getting? 60 kilometers divided by 2 hours, nothing but 30 kmph, correct? So this is what speed? This is nothing but the average speed. Now if I am telling you another case, suppose during this 2.5 hours, the vehicle has stopped for half an hour for any purpose, maybe for shopping, or he stopped somewhere after seeing his friend or something, or in between few minutes he got some red signal in the intersection. Like that I am telling, only for 1.5 hours he was traveling actually, or he was running, his vehicle was under motion only for 1.5 hours, and the remaining 30 minutes was completely delayed. Okay, so if I am considering that delay, means the vehicle was under rest, 0 speed, then what speed I will be getting? Another speed I am going to get 60 kmph divided by 1.5 hours. Then if I do 60 divided by 1.5 hours, how much I am going to get? I will be getting 40 kmph. Right? So different average speed we got, correct? So in the first case we were not considering the delay of the vehicle. So this thing, this particular speed, we call it as overall speed. Overall speed or journey speed or travel speed, all are same. But this one where we are considering the delay also, we call it as running speed. Okay, this is running speed, this is overall or journey speed. So what we can understand, this average speed itself can be splitted into two. It can be either your running speed or it can be your travel speed. So in various exams like state government exams, SSC, stage 1 exams, they can ask you questions, maybe in various state exams also, they can give you some sentences. We may have to choose the right sentences, correct sentences. So which one will be more, whether journey speed or travel speed will be more or running speed will be more? Obviously we know in the running speed only we are eliminating that delay. In this overall speed we are taking the total time. In the running speed, total time minus delay. So the denominator is less in case of running speed. So always your running speed will be more than travel speed. So that point you can note down. Running speed will be always more than your travel speed. Now what can be the next type of speed? Whenever you are riding your vehicle, if you are looking at the speedometer of your vehicle, what you are getting? At that particular instant, what is your speed, right? It keep on changes. If you are applying brake, it will lower. If you are accelerating, it will come up. So this is an average speed, but practically it doesn't mean that every time you are going at this average speed, it keep on varies. So at a particular time, what is your speed, or at a particular instant, what is your speed? We call that speed as, simply we can call instantaneous speed. At a particular instant, what is your speed? Okay. So I can also call this instantaneous speed as sports speed. Instantaneous speed, or what is the definition of sports speed? Nothing but the instantaneous speed. So at that sport, what is the speed? Like that. So sport speed is very, very important in our traffic analysis and all. We have to, if you want to do that accident analysis, if you want to make some different traffic control measures, if you want to calculate the capacity studies, everywhere sports speed is very, very, very important. Okay, so we are going to see in detail what is sports speed study, very important for competitive exams. So this word also you should remember. What is sports speed? It is the instantaneous speed of a particular vehicle. Okay, so now we will see what is sports speed, that in detail. The definition we have already seen, nothing but the what is the speed of that particular vehicle at that particular instant. We are having so many instruments to measure what is a sports speed. Okay, so if you are riding the vehicle, then if you are looking at the speedometer, we can understand what is the sports speed. But suppose if you are riding the vehicle, I want to know your speed, then how can I check that? Okay, only you can check your speedometer, right? So what we will be doing, we are having different instruments. Different instruments are there, like photoelectric instrument is there, radar instrument is there, there is an instrument called as Enoscope. Out of all these instruments, photographic method we can use. Out of all these instruments, there are two instruments which are very important, which are nothing but Enoscope. This is already asked in GATE exam also, various state exam also, they will be asking these questions. Enoscope method as well as speed gun method. These are the two instruments, very important instruments we are using to find the sports speed. Enoscope is very simple method, anyone can do that experiment, but chances of errors is more. So that's why nowadays we are preferring speed gun. So I will tell you what is first Enoscope, then I will tell you what is speed gun. Okay, so Enoscope is nothing but, suppose if you are having a road stretch here. So this is a particular road stretch. So many vehicles are coming. Okay, so first what we will do, we will particularly select a stretch here, and here we are going to stand to check what is the speed of the vehicle. Okay, now we are explaining what is Enoscope method. Okay, right. So whenever these vehicles are crossing this particular location, we will start our stopwatch. Okay, and we will select another stretch somewhere here, which is somewhat very near, maximum to maximum 20 to 30 meters. It shouldn't be too much more, okay, too much distance. So whenever a particular vehicle is crossing this particular stretch, we are going to start our stopwatch, and when it is moving and crossing this particular stretch, we are going to stop our stopwatch. Then we will be getting the time that particular vehicle has taken to travel from the point A to B. Correct? So if you know the distance, it is 20 meter or 30 meter, we know that already. If you are dividing the time taken, what we will be getting? We will be getting the speed of the vehicle. But see, now you may be thinking, then it is going to be the average speed, right? Yes, it is the average speed, but where we are going to do this survey, actually on a very long stretch, maybe in a national highway and all, where there is no other minor road is meeting, there is no speed breaker, there is no intersection in the front. Such a road only we will select, and we are assuming that if a vehicle is coming on a national highway where there is no other disturbances, if he is moving at 50 kmph or if he is passing this particular stretch A at 50 kilometers per hour, then we are assuming that just in the next 20 minutes, 20 meters, he may not be increasing his speed or he may not be decreasing his speed. We assume that it is going at constant speed. So even if you are taking distance by time, you are going to get that same value of speed only. That's why we are telling this distance shouldn't be too much. If it is too much distance, 100 meter and all, then in between he might have applied brake or he might have accelerated and all. That's why we are taking a small stretch. We are assuming he is going at constant speed. So at any instant, if you are checking what is the speed, you are going to get the same speed. That's why we are assuming that is equal to the spot speed. Now, where we have used our instrument now? We haven't used our Enoscope anywhere, right? So where we are using this instrument, see, we know whenever the vehicle is crossing the point A, we are standing there, so we can easily start our stopwatch. But we don't know when exactly this vehicle is crossing the point B. So to understand that, what we will do, we will keep a tripod here. On the tripod, we will keep our Enoscope instrument. So Enoscope instrument is actually having a mirror kept at 45 degree. If I am just magnifying it, so it has a mirror. This is a mirror which is kept at, so this is a mirror which is kept at 45 degree. So if you are keeping a mirror at 45 degree, what is the advantage? See, whenever that vehicle is crossing, you will be getting the reflection wherever you are standing. So we'll exactly understand. We just have to look at that mirror which is kept on that, or Enoscope which is kept on the tripod. So whenever that vehicle is crossing, we will be getting that reflection there. So that time we can stop our stopwatch. Understood? So this instrument is called as Enoscope, which has a mirror of 45 degree. That's why we are getting, if it is not 45 degree, we will not get that reflection perpendicular, right? That's why we are keeping at 45 degree. Okay. So that's it. If you are getting the time taken, starting and stopping the stopwatch, we will be getting the time. So that particular distance, we know this distance already, maybe some 20 meter divided by that time, particular time, we will be getting the speed of that vehicle. Obviously this is in meter, this may be in seconds, within seconds it may be crossing, right? So we may be getting the speed, definitely not maybe, we are going to get the speed in meter per second. Later we can convert into kilometers per hour, okay, for accident analysis or for intersection designs or for capacity calculations. We have to check the value in, we generally used to take the values in kmph. So I hope you understood what is Enoscope. Now I will tell you what is speed gun. See, in speed gun it is very simple, no need to do any calculations and all. I will show you an image. See, on the screen you can see an image. So what is this instrument? Nothing but speed gun. So whenever vehicles are coming on the road, where actually this policeman is standing, maybe on an overbridge and all. So maybe from we can do the same survey by standing on the roadside also, or anywhere wherever it is convenient. So what we are doing, it's working on the principle of Doppler effect. So a ray will be going into that particular vehicle, then it will receive that ray back, it will receive that signal back. Okay, this one we are calling it as speed gun or radar speed gun. See, on the screen you are seeing 42, it is written up, which means for this particular vehicle, whenever we are just pressing that button, it's like a gun. That's why the name came as speed gun. Whenever vehicles are coming, we just have to aim it, press that button, then on the screen you will directly getting 42 or 50 or 60, like that, what is the speed of that particular vehicle. Okay, so some advanced technology, it's very nice for us, no need to calculate the time and do the calculation. And see, in the Enoscope method, the chances of making mistake is also more, error chance is more, because it's completely up to you when you are going to click on the when you are going to stop the stopwatch. You may be seeing the reflection. If you are exactly pressing the stop button that time, you are going to get exact time. If you are delaying for 1 second, then your speed is going to be changed. Again you are converting into kilometers per hour, then again that variation will come. Okay, so speed gun we are directly or radar speed gun, it's also called as radar speed gun. So it is using the principle of Doppler effect. So such questions may be asked in various state government exams and all. Doppler effect. So directly we are going to get, so it's a direct method. This is somewhat indirect, we are going to calculate distance by time. So in speed gun we are going to directly get the value. Now we are moving into two important definitions. The first one is time mean speed. So we have seen how we are going to calculate the sports speed, right? Using our speed gun generally. That's what we are using on the field. So suppose if I am calculating different sports speeds, suppose 5 vehicles are coming and I have found that their sports speeds are V1, V2, V3, V4 and V5 respectively, for example. Now if I am taking the average of those sports speed, previously what we have discussed, average speed means for a particular vehicle distance by time. Now what I am telling, the average of these sports speed values of different vehicles. What I will be getting, simply V1 plus, V2 plus, V3 plus, see whatever be the number of vehicles, etc. up to Vn. According to this particular example, till V5 divided by the total number. If I am taking, say, etc. Vn, let it be general case. Okay, Vn. There are n vehicles, so divide by n. What I will get? The time mean speed. We can put it as Vt. So what is this? Nothing but the average of, or I can call it as the arithmetic mean of sports speed values. The arithmetic mean of sports speed values, we can call it as time mean speed. Okay, then there is another definition which is nothing but space mean speed. Now what do you mean by space mean speed? Nothing but if you take the harmonic mean. What do you mean by harmonic mean? If you are substituting Vs, if you are denoting it as Vs, what do you mean by harmonic mean? Nothing but if there are n vehicles, n divided by 1 by V1 plus 1 by V2 plus 1 by V3, etc. Whatever be the number of vehicles it is there, 1 by Vn. Understood? So this one we can call it as harmonic mean. So what is the meaning of this space mean speed and time mean speed? Nothing but the average speed of, or average of sports speeds of different vehicles. Time mean speed indicates that at a particular time. Space mean speed indicates at a particular location, if you are considering n number of vehicles, what is the average of those vehicles. So very easy, very simple and all. What do you mean by time mean speed? At a particular instant, if you consider different vehicles, some n vehicle, and you calculate the sport speed of all those n vehicle, what is the average of those sport speeds? Now space mean speed means if you consider n vehicles not at a particular time, simply at some duration on a particular stretch of road, maybe 1 kilometer like that, if you select different vehicle and if you calculate the sport speed of those vehicles and if you are calculating the average, but in that case instead of arithmetic mean you have to calculate the harmonic mean. We call it as space mean speed. Okay, so remember your time mean speed Vt will be always greater than Vs. So this thing you can remember, can be asked for various exams like state government exams and all. One thing you can remember, if all those values are same, if V1 equal to V2 equal to V3 equal to V4 like that, then this time mean speed and space mean speed are going to be equal. That you can check by putting some values. Okay, so I'm just giving you an example as a practice question. Let it be, if I am telling you there are 3 vehicles, okay, or 2 vehicles, let it be for calculation simplicity. There are 2 vehicles. First speed is 100 kilometers per hour. The second speed is 25 kilometers per hour, simply. So what will be the time mean speed? What will be the space mean speed? So you just calculate. I am also don't know the value as of now. No need to pause the video. You can calculate along with me. So what it will be? 100 plus 25 divided by 2. So this will be 2 divided by 1 by 100 plus 1 by 25. Correct? Yes, I am getting 40 kmph. Hope my calculation is correct. Okay. Understood how we are going to calculate? See, after calculating, one simple check what you can do. Whether your calculated value of Vt, you just check whether it is more than Vs or not. There is high chance that you may make mistake while doing the calculation of Vs if so many speed values are given. So in case if you are getting some value which is more than Vt, you can at least understand that you have made a mistake. Okay. So I am giving another question which you can practice. So just calculate these values also. I'm also not having the answers. So we can solve together. Take the calci and watch the video. 40 plus 50 divided by 3. 46.67 kmph, right? Vs will be 3 divided by 1 by 50 plus 1 by 40 plus 1 by 50. See, remember, if they are giving 2 identical values, take it uniquely, okay? Different vehicle they are. Yes, 46.153 kmph, right? See, in gate exam and all, to save time, 1 by 50 plus 1 by 50, you directly calculate 2 by 50 plus 1 by 40 like that. Okay, then if it is in gate exam, then you can put 1 by x. There is an option 1 by x. Then multiply with 3. So I hope you understood what is how to calculate the time mean speed and how to calculate the space mean speed. See, as of now, how we have represented, simply 50, 40, 50 like that we have seen one example. In the other example, 100, 25 like that we have written. Suppose if I want to write some 1000 number of vehicles or some 500 vehicles, we cannot simply put it by write it by putting comma and all. Now we cannot read it properly. So whenever we are having too many data, the best method is to represent in a graph. So how we are going to represent the sport speed data? We'll keep the cumulative percentage frequency on y-axis. We'll keep speed on the x-axis. You might have used the same type of y-axis and x-axis in geotechnicals, sieve analysis. There also we are doing percentage, cumulative percentage on y-axis, cumulative percentage passing now on y-axis, and we'll be taking the sieve size on x-axis. So there also we got a graph which is in this shape. We call it as an S curve. So those who already know how we are going to draw it, you can directly go to this particular type. Now we are going to discuss how we are going to draw this graph. It is not required for gate exams and all how we are going to draw the graph, because directly they will ask you the question. Okay, but for your knowledge, I'm explaining how we are going to draw this graph, how we are going to get it. Okay, so those who already know, we can directly go to this particular type. Okay, now just to understand how we are going to draw that graph. First of all, doing the survey, we'll use the speed gun and we are going to check the speed of each vehicle. Then after calculating each vehicle, we'll make a graph, we'll make a column first of all. We'll split that into different speed ranges, 0 to 10, 10 to 20, 20 to 30, like that. Maybe if some vehicles are there which are having more than 100, then we'll keep one more row here. I'm just keeping from 0 to 100, that's it. Whatever be, suppose one vehicle is coming at 120 kmph, then we have to keep 100 to 120 like that also. Okay. So what do you mean by frequency? Nothing but how many vehicles are there in the range 0 to 10. Or 204 means how many vehicles are there in the range 40 to 50, like that. That is the meaning of frequency. So this is the data we are getting on the field. So using this data, now we are going into, or see, this frequency also we are not directly getting in the field. We'll just count it. Okay, later using the Excel sheet, we can put it into speed range and frequency graph. Now what is the next stage? Now, see, whenever we are having a range of data, for calculation purposes, we'll keep the mid value like this. Okay, as of now, I'm just keeping it there. I'm not using it. Later, I will use it while drawing the graph. So, till frequency we were having in the previous Excel sheet itself. Now, what we will do, we'll take the sum of that. You can see the equation here, sum of from here, from this 12, 18 plus 68 plus like that till plus 9. We'll be getting this 850. Now how we are going to calculate this percentage frequency? You can simply see, I can show here, equal to this particular frequency divided with the total number. I want in percentage, so I'm multiplying with 100 also. Now I'll be getting 1.41 percentage. Understood? Similarly, equal to this particular frequency divided with the total value, multiply with 100. Why 100? I want to convert into percentage. Okay, so similarly I'm going to calculate everything. Yes, I have calculated all those percentage frequency. Now what we have to do? Cumulative percentage frequency. So what is the meaning of cumulative percent frequency? Nothing but the first one will be exactly equal to this particular frequency. The second one will be the previous value plus the current value. Okay, equal to, you will be getting the answer. Similarly, the next one will be the previous value plus the current value. That is the meaning of cumulative percentage. We are keep on adding it. Yes, finally, whenever you are calculating all the things, you have to get 100%. Okay, so you can check that. In case if you made any mistake, finally you will not be getting 100%. See, it depends if you are taking the decimals round off to, if you are rounding off the decimals somewhere, then finally you may be getting 99.99 or 100.01, like that you may get. Depends on how you are rounding of the decimals, but doesn't matter if you are getting 99.99 or 100.001, which means your calculation is correct only. Only problem is that small rounding off. That doesn't matter. In college exams and all, it will be correct only. But you try to take some 3-4 decimals if it is asking in college exams, so that your calculations will be more correct. Okay. Now, so that's a check. Finally, if you are getting 100 means, okay, your calculation is, might not be any having mistake. If you are not getting 100, which means somewhere you made any mistake. Now, what you got? Now we are having the speed ranges in the first column. Then we are having cumulative percentage frequency in the final column. Now we can draw the graph by taking this column E on y-axis. Then see, it's a range now. We don't have any particular value. So to put those speed ranges on x-axis, we are doing this mid value. So 0 to 10 means middle value is 5, 10 to 20 middle value is 15. So Corresponds to 5, we are going to draw 1.41. Corresponds to 15 on x-axis, we are going to take 3.53 on y-axis. Like that we are going to draw the graph. Now we are going to get whatever we have seen in that previous sheet. Okay. Now I hope you understood how we are drawing the graph, cumulative percent frequency versus speed range. So we will be getting a shape like this, S-curve. Now what is important? Why we have drawn this graph? 3 important values we are going to get from this particular graph. So what are those? See, corresponds to 98 and corresponds to 85 and corresponds to 15. These 3 values we are going to take. So corresponds to 98, we will be getting a value here. Corresponds to 85, corresponds to 15. So we can just check that what is that value. I'm just putting if corresponds to 15. So here if you are checking, we will get a value corresponds to 85. Here if you check, the value corresponds to 98. I am representing V98. Okay. So these 3 values are very important for us. We are not considering the 100th percentile value. We are considering only 98. So this value corresponds to V98. We consider it as the design speed. Very important for various competitive exams. V85 we denote it as maximum speed limit. V15 we take it as minimum speed limit. So this is very important for us. So what is design speed then? 98th percentile speed. We call this V98 as 98th percentile speed. This is not percentage. Percentage means simply till 100%. Percentile means cumulative value we are taking. That's why percentile. So this one we can call it as 85th percentile speed. So 15th percentile speed. So they can ask you questions based on that. Already in GATE exam, question has been asked. I'm not showing the exact question. I'm just telling the question. The design speed is considered as options they may give: 98th percentile speed, 85th percentile speed, 15th percentile speed, some 30th percentile speed, like that they have asked. Okay. So hope you understood how we are going to represent it. Now I'm just going back to our previous data. Now see here, if you are checking this column D, what you are understanding, the percentage frequency, it keep on increases, then it is decreasing. So generally on the field it will be like that. The middle range around 40, 50, 60, that range you may be getting the maximum number of vehicles. Very slow moving vehicles will be very less in number. High speed vehicles, that also very less in number. In the medium range you may be getting maximum vehicles. Okay. So if you are taking, now we have seen column B versus column E. Now if you are drawing a graph, column B versus column D, what you are understanding? It keep on increases, then it is decreasing. Correct? Where it is maximum you are getting corresponds to 50, 60 or corresponds to mid value 55. You are getting maximum value 30. Correct? So if you are drawing a graph which is like this, which means what you understood, in the slower speed limit it's keep on increases, then it is decreasing. According to this data, what it is, maximum percentage is 30, corresponds to 55. So if I am just taking our example, corresponds to 55, you are getting maximum percentage as 30. Correct? This is what we are getting from our analysis. Okay. So if you are taking percentage frequency and speed, you will be getting an increasing and decreasing graph. If you are taking cumulative percentage frequency, it always an increasing graph, which is an S shape. Okay. So here, this particular speed, which is nothing but the speed which is maximum occurring, maximum number of times or maximum occurrence. Which speed that is? According to our example, it is 55. That speed we can call it as model speed. So what do you mean by model speed? Model speed is nothing but for a particular value, that whichever speed is occurring maximum number of times, we can call it as model speed. So I'm not giving another particular question. This one we can take it as a question. So if this is a question for our first data, if this is a question, from here itself what we can understand, see, maximum number of times occurring is 50 to 60. No need to convert into percentage. The concept I am telling, if you are drawing the percentage frequency versus speed range, whichever is occurring maximum, that one 50 to 60, we don't know exactly what is that value. That's why we are taking a mid range 55, like that. Now I am telling you another speed which is called as median speed. So what do you mean by median speed? As of now we have seen design speed, maximum speed limit, minimum speed limit, then model speed, now median speed. Now what do you mean by median speed? If I am simply writing some speed values, suppose 25 kmph, 40 kmph, 30 kmph, 50 kmph, 15 kmph, let it be. Now if I am arranging them in the increasing or decreasing order, how I will be getting increasing order if I am writing 15, 50, correct? So if I am increasing, or if I am writing in the increasing or decreasing order, whichever is coming in the middle, we call it as median speed. Okay, very simple concept. Understood? Increasing or decreasing order, the central value we call it as median speed. Now you can see a question which is asked in GATE 2016 to calculate the median speed. Okay, so just you write it in the order, then you just count it whether you have taken the exact same number. If you understood something is missing, then you add in between. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, now it is completed. Suppose see a same value. Suppose they have given one more 60 here. Then you have to add 62 times because they are two different vehicles. Okay, if they are giving same value 2 times, then 2 times you have to take. Now see, there are 10 values. 1, 2, 3, 4. This is the 5th one. This is the 6th one. 7, 8, 9, 10. Since it is an even number, we don't have a middle value, right? So what we have to do? Then we will take the average. So 53 plus 56 by 2. If there were 11 numbers, then directly I can take the 6th one, middle one. But now we are having only 10 even numbers, so take the average of the middle two values. So 53 plus 56 by 2, it will be 54.5 kmph. This is going to be your median. Understood? So this is a GATE question. So like that, any question they can ask you. See, this is one question. Speed and delay studies on a defined section of a highway are conducted by. I already told you, which is a removed topic from GATE examination, but they can ask you because it is somewhat related to speed and delay. We have studied why we are using Enoscope or why we are using speed gun. That is for sports speed. For sports speed we are using speed gun and Enoscope and all. That is an instantaneous speed. Whenever we want to calculate speed and delay, what is delay happening in between, then what method we are going to use? We are going to use the moving observer method. See, there are so many names for this moving observer method. Moving observer method is also called as moving car method. It is also called as floating car method. There are so many names like this. Floating car, moving observer and all. Okay. So speed and delay, it is considered as a single word. Okay. Single usage. Okay. So speed and delay, whenever you are seeing the word delay, you have to check for this three: moving observer, moving car, or moving floating car method. So what it will be? The correct answer will be moving car method. Another question which is asked in IS examination. What is this? Column A, column B matching. The same question can be asked for various state government exams, GATE exams and all. See, first thing we know, whenever we are seeing sports speed, we know either it can be Enoscope or it can be speed gun. So just check whether it is there. See, Doppler radar. We have already seen it's based on Doppler effect, radar, speed gun. So they are giving some other words. So C will be corresponds to 2. So that we can easily check. So C2, only Two options are there. So first of all, we can eliminate C and D. Now what is remaining? Speed and delay. That is also there. We know speed and delay study means moving car method. So just check whether it is there or not. Yes, see, floating car method. I told you different names they will use. So B will be corresponds to 3. Yes, all the available. Now we are having only two options, A and B. It is also given same. So that is also completed. Now what is remaining? Traffic volume study means traffic counting. Either we can count manually or using some pneumatic tube or electronic equipments and all, right, for detecting. So word spot interview, no. Floating car method, automatic, electronic detector. See, or see, it can be other. See, suppose automatic vehicle counter, it can be, but automatic counter means it's a manual. Classifier means manual method. Automatic devices means whatever we have seen. See, this is also an automatic devices. Pneumatic tube is there. Why we are using counter and classifier? It's an equipment. Classifier means particularly you want to check what kind of vehicle it is. Generally, high error will be coming if it is an automatic device. That's why we are using manual method. Okay. So this A will be corresponds to electronic detector 5. So where it is? Yes. So we already got it is option A. You can just check option D what it is. Multiple characteristic study. Yes, that's why I told what are the different types of vehicle. If you can find out using automatic devices, highly modern equipment this is, but chance of making or a chance of errors is more. That's why we are preferring manual method for checking, for classifying the vehicles. Okay, so in this question option will be A, right? So if I am taking another AES question, which one of the following equipment is useful for determining sport speed? What will be the equipment for sport speed? Nothing but Enoscope. See, radar is also the right answer. So both A and C were the correct answer. Actually, they have to give radar speed gun and all. So they might have taken only option A as the right answer. Nowadays we know. Suppose the question is radar speed gun. We know MSQ question is also started in a GATE exam from 2020-21 onwards, right? So if this is a GATE question coming for you, then what will be the answer? Both A and C. That is going to be an MSQ question. Correct? In GATE exam they have introduced this MSQ. The same question is already asked for GATE exam also, that I am not showing you. So there, this option was not there, radar option was not there. They have given 3 different other options along with Enoscope. That is a GATE question which is asked. I have not pasted that here. Same question. Okay. So I hope you understood how to calculate different types of speed and all. One small thing I am just telling you. See, suppose I told you 98th percentile speed is nothing but your design speed, right? So here we are not directly getting 98. We are getting in between 98.94 and 95. Similarly, 85th percentile speed we are not getting here. We are getting only 76 and 90. So if you are drawing a graph, then easily we can get. Suppose if it is coming for your college exams or some other exams, and if you want to calculate it, how we will do it? We will do the interpolation. Even if you are doing interpolation, it may not be exactly correct, because interpolation means it should be linear variation, correct? Here what variation you are having? You are having a S-curve. It's somewhat a non-linear. So if you are doing the interpolation, then also it may not be exactly correct. In case in your college exams, if they are asking, we can do the interpolation and we can find it. Somewhere it will be approximately correct. So if you want to check how to calculate it, for example, I am taking 85th. If this is a question for your exam, see if this is the data and they are asking you to calculate the maximum speed limit. So maximum speed limit means what? 85th percentile speed. So I am drawing this sheet, then corresponds to 85th means, see I am not getting 85 here. So what we have to do? We have to take these two values and we have to interpolate it. So corresponds to 55, we are having 76. Corresponds to 65, we are having 90. Okay, so those who already know interpolation, the video is over. Those who want to know how to do the interpolation, I'm just explaining that. So two values, what are those two values? Corresponds to 76%. We are having the speed as 55 kmph. Now corresponds to 90%. So 65, I am writing somewhere here. So what we are going to calculate now corresponds to 85. What is the value? So which you already know, that we will put it on the horizontal line here. What you are going to calculate, that we will put on this y-axis somewhere here. Now I am drawing, simply putting joining it as a straight line. So this one v corresponds to 85. This is what we have to find out. So how we are going to find out? Very simple. Just put a horizontal line here. Just put a vertical line here. Just take the tan theta. That's it. So tan theta means what? Slope of this blue line. Tan theta, slope of the line will be always same. So what will be tan theta? I'm just writing somewhere above. So what is going to be tan theta? Nothing but we know this y1 divided by x1. This complete. Let me use some other color for better understanding. Yes. So tan theta, if I am taking, this is y1 and this whole portion as x1. What I can write? Tan theta is equal to, what is this value? 65 minus 55 divided by, what is this horizontal? 90 minus 76. So that should be equal to this y2 divided by x2. So what it will be? Y2 is nothing but the unknown value of v, suffix I am putting 85, v minus 55 divided by what will be that x value? 85 minus 76. So if you are calculating, so 65 minus 55 is 10 divided by 14 is equal to the unknown value corresponds to 85th percentile minus 55 divided by how much it will be? 9, right? So if you calculate V85, if you calculate how much you are going to get? 61.42 kilometers per hour. Okay, right? So I hope I have completed almost all the things related to traffic counting and traffic speed. Right, so I hope you understood the concepts which we have discussed. If you have any doubt in between anywhere, you can ask in the comment box. I will reply there. Okay, so that's it. We are winding up. Hope you understood all the concept. Thanks for watching.